Yeah, hello, sir.
Yes.
Yeah, okay, sir. I will start from my side.
Okay.
Yeah, okay. So, good morning, Dr. Samir Jain, and good morning to the participants who are watching this live session. So, ladies and gentlemen, and esteemed guests, and welcome to our session on data analytics and visualization, communicating insights for decision makers. So, we are thrilled to have you join us as we delve into the transformative power of data in today's decision making landscape. In an era where information is abundant yet overwhelming, the ability to distill complex data into clear and actionable insights has never been more crucial. Today, we will explore how effective data analytics and visualization techniques can elevate your strategic decision making process. Whether you are a seasoned executive, a budding entrepreneur, or a data enthusiast, this session is designed to equip you with the tools to interpret data meaningfully and present it compellingly. By harnessing the latest methodologies in analytics and visualization, you cannot only enhance your understanding of trends and patterns, but also drive impactful decisions within your organization. As we embark on this journey together, we encourage you to engage actively and ask questions and share your experiences. Let's unlock the potential of data and uncover the stories it tells, empowering you to make informed decisions that can shape the future of your projects and initiatives. So, thank you for being here and let's get started. Okay. So, before we start Dr. Samir's session, I would like to give some short introduction about him. So it's with great pleasure that we welcome our esteemed guest speaker, Dr. Samir Jain, to today's session. So Dr. Jain is a distinguished academic and industry expert whose impressive and diverse educational background sets him apart in the fields of computer science and engineering, information technology, and beyond. With a PhD and numerous advanced degrees, including a bachelor's from Nagpur University and a master's in technology, his commitment to lifelong learning is evident. He has earned accolades such as a gold medal from JB University, highlighting his exceptional academic achievements and dedication to excellence. Dr. Jain's professional journey is equally remarkable, having held significant roles at esteemed organizations like Delhi Transport Limited, ST Microelectronics, and NMMS University Mumbai. His innovative teaching methods have made a profound impact on his students, and his contributions to academia are widely recognized. And notably, he has received prestigious awards, including the Gold Medalist and Special Recognition Award from the Confederation of Indian Industry, as well as the Digital Transformation Award from Associum, and underscoring his influential work in driving industry innovations. And active researcher Dr. Jain has published over 50 papers in prominent outlets focusing on the digital transformation of construction management. His extensive expertise encompasses cutting edge fields such as analytics, machine learning, blockchain, and risk management, of all which are crucial for navigating today's rapidly evolving technological landscape. And we are excited to hear his insights today and look forward to the invaluable knowledge and he will share with us. So please join me in warmly welcoming Dr. Samir Jain. So before the session, I would like to give a short intro about our services at Thames Tech Solutions, a pioneering series venture. So our company is dedicated to developing innovative engineering, management, and scientific tech solutions and tailored to support our ecosystem with our forward-thinking approach. We pride ourselves on offering affordable services and robust support backed by a professional and skilled team ready to deliver exceptional business plans. And Thames Tech Solutions specializes in comprehensive array of services including digital marketing, web designing, server management, on-field marketing, Android and iOS app development, telecommunications, AI tools, SEO, and web analytics. We also excel in business operations and process automation across the various sectors, such as industrial research, mechanical and automobile, aeromobile and defense, electronics and energy, architecture, civil engineering, medical applications, maritime and marine, agriculture, and more. So, additionally, we are passionate about the education through Mastering a Platform. It's a free platform aimed at unlocking skills for a brighter future. We invite you to join us and in empowering young learners by sharing your knowledge and expertise. So, our guest lectures is foster skill development and knowledge sharing and personal growth, and offering a platform to inspire, educate, and connect with an enthusiastic audience to eager to learn. So, at the end, I would like to introduce to the motto of Dr. Sami Jain: empowering innovation through knowledge and collaboration. So I would like to hand over the session to Dr. Samit Jain, and also thanks a lot for joining us today. And over to you, sir.
Thank you, madam, for the great introductions. So let me begin the things. You have covered many things the with respect to analytics and with respect to visualizations. I don't know who are your audience, but I might that we might have justice for this the next 1 hour, so they may get some insights. Many of them they are aware what is analytics nowadays. It is in the space. Every newspapers, every magazine has covered all these topics nowadays, but the point is how do we make the money through the businesses. That is the main motto of these kind of sessions, and understanding the patterns in the business where you can convert the problem statement into the business problems, and then from business problems come out with various solutions. Maybe the solution is like at operational level solutions, or middle level managers solutions, or the strategic solutions. So one problem might get many solutions out of the data, and that is the specialty of data analytics. So you could not have only one solutions. You could have many solutions of single data sets. Only thing is how we deep dive into multiple approaches to get into it, and we can present those solution in terms of presenting those solution to the clients, to the consultants, and satisfy them in the form of maybe optimizing the resources, or enhancing the productivity or efficiency sort of things. So again, it depends on the business problem statement and the domain where the people are working. So the today's topic is mix of two things. One is the analytics, which is purely data, and the other is the visualization. Again, it is a pure data. But analytics means you do analyze with the through the data, and it requires some sort of technologies behind it. So if you have the technology, if you have the data, which means the raw data in the form of numbers, facts, raw images, text data, image data, speech data, video data, whatever it is. So you deep dive into it, and get some insights, so that you can make an informed decisions, and make your processes sound, and enhance the productivity which is there in the business. And second is how do we present those data in front of the client, in front of the management, in front of the consultants, or maybe some other stakeholders, where you need to uh, define your problem statement, and make investment decisions, or some sort of decisions where money is involved, or risk is involved. So in that way, the presentable things plays a very important role. So it is not in the form of pie chart, it is not in the form of bar chart, it is not in the form of other charts, but it is in the form of thousands of hundreds of charts, where you can learn all those things and try and presenting in various formats, and so that you are able to communicate both data through the problem plus the presentations, and that is the communication aspects, so that one has to take the decisions, and they can satisfy the entire stakeholders which are there into the business. So this is the outline of the topic, because first we need to understand the topic, and then we can deep dive it. So the next question arises: what is in analytics basically? So the professor W.H. Deming is the Harvard professor. He said Without data, you are just another person with an opinion, right? So if let's say you want to understand or you want to learn any programming language, so it is like you need some tool where you can put your brain, you can put your concepts, you can play around with that language, and then you can come out with the solution. Same as in the business. So if you have data, then you can deep dive into it, you can bring some insights, right? And then you can place you can define some sort of solutions from those problem statements. But if you don't have any data, it means you are a person with an opinion, which does not mean any value in the business, right? So if you want to learn something in computer, you need a computer. If you want to do something with business, you need a data. So without data, you're just another person with an opinion. It is known as, one professor said that data is a new oil, which means it is a resource. So data is a resource where you can make the money. So if you have more resources, then more skills are required, smart skills are required, or comprehensive skills are required, so that you can make more money out of it. So if you have less resource, again, there are complexities involved. But if you have more resource, which is more data, then again, you are in the side of upper side, where you can deep dive into it, and you can create many models, many types of models. One is for the internal model, another is for the external model. Internal model means within the organization, external model is out, means out of the organizations, which is meant for the client, which is meant for the users, which is meant for other state, maybe for the government, and so and so forth. Now, if you look at the insights data, we are generating every minute of the day. So look at this. Everybody knows that once you start any activity in the morning till once you get down on the bed in the late night, you have mobile in your hand, you have TV, mobile, laptop, desktop, many screens. Maybe you visit railway station, you visit uh, any sort of utilities or any sort of infrastructures kind of stuff, maybe airport and sort of things you need. You find there are screens available where you can see the videos, you can chat, some sort of applications are there, you can land up some hotels where screens are there, you can engage yourself with them, and try and generate the data through the apps. For example, many of you are online right now. So again, we are generating a data through the YouTube channel or through other channels. I don't know what channels they're using for streaming. So if you look at the data, 3.47 millions every minute of the day are online through the, or streaming through the online video watched. Look at the data. Next is 452K hours of content stream on Netflix every minute. 625 million videos watched on TikTok. 3.5 billion Snapchat created. 66K photos and videos shared on Instagram. So this is not a day data, this is not an hour data, this is not a week data. This is the minute data. So if you look at the volume and the velocity of the data, and if you look at the right hand side, how do you take this data and generate the businesses? So you need a technologies, you need an automations, then you can serve analytics as a service, which means real time. For example, if you order something through Zomato, and if, so now if let's say World Cup is going on, or some sort of cricket match is going on, or some sort of uh, uh, sports events are going on, or some sort of political events are going on, and you need to order a samosa kind of stuff, or some sort of dish from Zomato or through say Swiggy. Now, if in a city like Pune or Mumbai, if 2 lakh or 3 lakh people are tapped that they need to taste a samosa from Haldiram or any sort of sweet vendors, then look at the volume in 1 minute or in 2 minutes, because we don't know the background, what is going on, what is happening there, how many people are ordering samosa, or how many people are ordering burger or pizza from different stakeholders, from different vendors, and so on and so forth. Now, if 2 lakh people are giving the same amount of order and same amount of time, then what happened? The delay has happened. Now, how do you manage those delay? Physically, it is not possible. So now the technology plays a very important role behind it. So for that, you need to apply analytics as a service, where you can give the automation messages to the users that, boss, your pizza would be delivered by 10 minutes late or 15 minutes late because of some reasons, because of any unforeseen reason, and so and so. This messages cannot be float by the users. This message is floated by the technologies, which is backend, which means they notify the users based on the current situations which is going on. So maybe through IoT, maybe through some technologies behind it, let's say IoT, Internet of Things, where they place in sensors in the cloud kitchens, and then based on the orders, and based on the delivery, based on the parcels they have received, and so on and so forth, based on the inventory what they have it. So multiple variables are there, and accordingly the decision making has been happened on the dashboard which they have placed on the businesses. So all decision has been taken on the real time basis, but the technology plays a very important role. You cannot serve 2 lakh people in 5 minutes or 10 minutes time through the physical mode. Technology plays a major role to deliver, to address those kind of problem statement. Similarly, healthcare problems, similarly education problem, similarly the construction problem, similarly the real estate problem, and many more, right? So there are many things. You can solve it through analytics, you can solve it through automations, you can solve it through data mining, you can solve it through kind of predictive modeling. For example, what is prediction modeling? For example, in the side of stock exchange, so if I invest 1 rupee, do I get 2 rupees at the end of the day? Do I get 2 rupees at the end of the week? Do I get 2 rupees at the end of the month? This is the problem statement that the user has made it all the time, and they analyze themselves that how do I make more money out of it if I do invest 10 rupees, 100 rupees in a day, for example. This is just an example to understand that if today these are the stocks which are in upper side, so if I invest today, what will be the gain in the next day or next week or next month or next year, and so on and so forth. So again, predictive modeling plays a very important role. So for example, if the rains are there outside, so again there is a prediction that do I take my umbrella before I exit my home, or or will not. So again, it is known as predictive, right? So all those sort of things you can predict it. So many times prediction are fails, but is still 99% people are doing predictive, right? So that is what you're solving the problem of yes or no. So for example, there are many businesses, shadi.com, jeevanshati.com, right? Then makemytrip.com, indianrailways.com, and so on and so forth. What for? They're solving the problem of yes or no. So what is yes or no? For example, if you want to find someone based on your bio and some other bios, so if you are male, you're finding a woman. If you're woman, you're finding a male partners. So in that way, what is the probability that what I'm looking forward, the same thing I may get it? So again, this is a problem of yes or no. So if I'm searching and I'm getting, that is known as yes. So again, there are various problems that the people are solving with the help of yes or no. But again, if full yes is not there, then what is the probability? Maybe 50%, maybe 60%. For example, if you book a railway ticket from the IRCTC, so what are the chances if you book a ticket on the waiting side? So if the waiting is 1 or 2 or 10, then might be the probabilities are more to get confirmed or in the RAC. But if the waiting are more than 100 or 200, then the chances of getting seat is less. So in this way you can predict, and that is how the backend models are working based on the volume and variety and the velocity, so that they are playing with the data. Next is, what is the difference between these two components? One is the analytics and the other is the visualizations, and both have a prefix of data. So data analytics and data visualization. Basically, data analytics is a process where you can examine to identify the patterns. So what is a patterns? It is a series of combinations. For example, if there are 2 3, then I just skip the number 4 and then I say 2 3 dash 5. So what is missing number 4? Because this is a pattern 2 3 4 5 and so and so forth. So it is a pattern where you can examine through the data, and it is a process where you can define discovery, which means search, interpretation, which means you can do the process with the data and come out with some sort of results. That is known as, you're going to interpret those data in the form of graphs or in the form of bar chart or in the form of pie chart, and then you are going to communicate it. That, for example, if there are two kind of categories, male and female, for example. So how many of you like burger, how many of you like pizza, for example? So let's say 60% people like pizza, 40% people like burger from the same shop. So it is known as, first is find out the shop where people are like more pizzas than burgers. So this is known as discovery. Now what is interpretation? 60%, 40%. And then you're going to communicate it. So now the communication has happened. Again, you can classify the pizzas, that which pizzas are more sellable out of 60%, which burgers are more sellable out of 40%, and so and so. So then you can come out with the meaningful informations to draw the conclusion and inform decision making, because at the end of the day you have to store the inventory. Without inventory you cannot survey to the users. So again, inventory plays a very important role, people plays a very important role, resources plays a very important role, and the the place where you are doing a business, that is also plays a very important role. So that is known as business decision, usually with the help of specialized software or tools. Next is visualization. So it is a purely presentation, right? It is a purely presentation of data in a pictorial or graphical format, and it enables decision makers to see analytics presented visually. So one is you have to deep down with the analytics, come out with some sort of meaningful informations from there, and then you're going to present it, those meaningful information in the form of visualization, so that you can grasp difficult concepts or identify new patterns. And that has been quoted by the Simon Samuel. It is a scientist who defined this three-line statement, which carries a lot of things: presentation, decision makers to see analytics whether it been properly fitted or not, and then you can identify the new patterns from the data. Because from data, it is not only one thing that you can identify, there are many things you can identify through the data. And that is how I listed there are four things which are very important. One is communication presentations, second is the analytics, third is the new patterns, and the final is the business decisions. Now, what are the typical roles in analytics? So on the left hand side there are four things which are required to solve or to deal with the data. One is, well, if you are in a business, what business you are in, which domain you are in, what data you gather from those businesses, what maths are required to solve that problem. For example, if you say you are dealing with video streaming or speech data, so speech data, from where do you get the speech data? Maybe from the bank, where they post the voiceover over there, it maybe in the airport, for example. And then you apply those techniques, you do apply those methods to come out with some insights through the tools, through the technologies, and solve the problem. So one is the left hand side, which carries business, which means the domain. Then what type of data you collected from those domain, then what type of maths, statistics, and quants techniques are required to solve those problems, and what tools you are going to adopted for solving these three things through the analytics domain. Now if you look at the right hand side, so if let's say you are the CEO of the company, for example, or you to be CEO of the company, then you have to define the roles of each individuals. So let's say if some people are in the business side, so they analyze the business, they understand the problem first, and then you deploy the managers to understand, to solve those problems in the form of various ways. For example, inventory is the one problem which are there into the business, then production is the another problems, supply chain is the third problem, right? Then marketing is another problems, then planning is another problems, billing is another problems, supplier managing supplier is another problems, right? If you quote a tender, let's say if you're in the construction business, so tendering bidding is another problem statement. So what type of business you are in, and then accordingly you're going to hire the people, they're going to solve the problem accordingly. And then next layer is the from the top side, next layer is the data analyst. So one is, once business problem is defined, once the domain is defined, once the problem is freeze, then this will go to the data analyst. So now what did data analysts do? They can clean the data, they can pre-process the data, they can understand that what is the error in the data, they can remove the values, remove the noises which are there into the data, and then it will go into the data scientist, where they can put the algorithms, and then they can do some sort of modeling into it, and then it will go into the data engineers or data architects. So which means every user has their own expertise into it. And if you look at, let's say, data scientists can do every sort of work. Data engineers, they can build an algorithms, new algorithms or hybrid algorithm. For example, if there are 20 algorithms are available, they can take it one or two algorithms, mismatch, try and find out the accuracies, precision level, specificity, and so forth. Data architect, so what is the specimen of the data, right? So what is the schematic of the data, so that we can build some database, and it is easy to, for example, if you look at the Uber, for example, so they can use Michael Angelo kind of platforms. So they have different architects of collecting the data of fleet data. where Uber taxis are there across globe, and they can put those data into that platform, so that the architect is unique and it is favorable to every stakeholders who are there on those particular domain area, right? So that is how the roles are defined, and one need all skills in different proportions. That is the statement. If you want to masters in all, then you need to deep dive in every steps. It is not like you can skip one steps and then you become the data scientist. Not like that. You have to go step by step, understanding each layers and try to figure it out. Yes, we are masters in all, and then we are taking the end-to-end problems. Maybe the domain problem, maybe the service related problem, maybe the policy making problem, or whatever it is. Sorry. So these are the kind of roles and skills are needed. For example, these, if you look at the jobs in organization, so there are, just this is just an example to understand. So if one has to become the data analyst, so they need their, what are their typical roles? They have to mine the data, applying techniques to supply insight to business in the form of reports or other visualizations. And what skills are needed? They need to understand how data is readable, so which means data expert. Basic statistics, for example, how do we find out the summary statistics through the data? For example, mean, mode, median, cutoffs, uh, percentile, and so on and so forth. Strong programming skills, at least one language. There is no need to of going for multiple languages. Just take one problem statement, one language, one data sets, and deep dive into it. Because ultimate is, how do you solve the problem? It is not like the tools are fancy and then you go many tools at one point of time. It is not needed at all. So you can pick one tool, you can pick a problem statement, you can take the data set, which is a raw things, which is an input to any of the tools, and then you can excel into that areas, so that you can deep dive in some organizations, maybe General Electric, Amazon, EY, aircraft, or Grofers, and so on and so forth. Next is business analyst, which means converting business problem into the data problem using some techniques called as analytic problems or analytic techniques to solve them. So what is that? Which means domain expert. So my call is, if you learn such kind of, or you gain such kind of skills, don't go into the maths directly, don't go into the statistics directly. That is important, no doubt. But first is, where do you apply all those things? Try and understand first the business problem statement. Spend at least a month time in some businesses. But yeah, what is that business? How, what is the behavior of that business? How they make the money out of it? What is their life cycle management? How, if the business is related to the projects, so what kind of projects they are doing? If they are making furniture items, what kind of furniture items they are made? What are the processes? And so that you are able to solve the problems. And then you have a good understanding of those data which you generated from those businesses. Then you apply in good way of statistics knowledge, and then of course that your skill programming language skills it help you a lot. And then you are a good storyteller of those businesses. And then the best example is, for example, consultancy firm JP Morgan, then you have a pro firm, then you have Amazon, VMware, Zoom card, and many more. Data scientist, it is advanced analytical techniques where they can understand more data, which means the big data to solve complex businesses and data problems. Which means, again, the aspect is understanding the domain knowledge or the business knowledge. You need to data expert. Advanced statistic knowledge means you need to test the various hypotheses, various permutation combinations using that data. So that is what the advanced thing of statistics. Hands-on coding expertise in machine learning, which means ML, data science. So there are open source tool named as R or R Studio. Then you have Python, and so and so. And there are various organizations who can hire data scientists and statisticians, named as Uber, Oyo, Citrix, Boeing, Swiss Re, G Healthcare, Rapido, and so on and so forth. Next is data analytics and manager. So managing a team of analysts and data scientists to deliver business solutions, which means small and medium organizations in business and domain knowledge, conceptual understanding of data, understanding of application, prior experience of programming, expertise of storytelling. So more or less, if you look at the data analyst, business analyst, data scientist, statistician, so everything means more or less the things are same. But only thing is, one, the complexities are less. In other domain the complexities are more, which means you're in one area you're solving a simple problem. For example, data cleaning job, or data standardization job, or data normalization job. So this is the job of data analyst. Another side, you are solving end to end. So you're doing the data part also, you're doing the modeling also, you're doing the production also, and so and so forth, and the presentation also. So, but all 4 5 steps are required in every roles and the job types which are presented in front of you, and various organizations pick up those candidates in the form of these context only. Now, how to build a successful career in analytics? You can break down the problem into steps. Marry means you can marry the business and the theory. So again, one is the learning aspects, which is important. Next is the business aspect. So if I learn the theory, what is the use of that theory? Do I apply in some sort of business which I don't know? So first is, if I know the theory, find out the business where you put those theory into the business, and this is doing while practicing. So spend time. Let's say if you are a college student, just look at here and there. If you have small shops, or if you have, let's say, tire factory or cement factory, or some sort of factory, or some sort of MSME sort of factories, where you can go there once in a week or once in a month. You can sit down there and speak with the manager, speak with the supervisor, and try and understand the business problem, so that your theory will be applicable to that particular domain, and then you're able to make the business model for them. Then master the art of storytelling. And once you understand the business problem, once you understand their data sets, kind of stuff, then you make the presentations for them, boss. Okay, so if you spend in supply chain x amount of money, can we save 10% of the money based on this kind of techniques, based on this kind of methods, based on this kind of tools, and things are like that. So you can master the art of storytelling while once you understand the things, and you can make a model for them. Keep your eyes and ear open, right? So what the people are saying, what your managers are saying, what your supervisors are saying, what your directors are saying, and so and so. And then of course, if you have one set of organizations who speak less, they are not interested on you, you can switch to another organization. Then whatever you learn in one organization, maybe 5% or 2%, you can apply that those in the next organization, so that they are communicating more and more from you, because you understand some bit of thing, bit pieces of knowledge, you have it in your head, and so that they are allowing you to communicating more and more things, and so that in that way you can make the networking. So maybe it will take some time, maybe 6 months time, or 1 year time, but after that, once you communicating those people, those networking peoples, then you are able to define the business problem easily, and try and figure out to come out with some sort of solutions, and where you can help them, and try to figure out the advanced solutions for those companies, where they can make the money, or they can enhance their productivity and the efficiencies in the processes. Now, why is data visualization important? Visualization means visual creatures. So something which are visuals, that is more important than the text data. That is more important than the numbers data, and so and so. So we are 90% visual beings, right? So we love to uh, understand the things in the form of visuals, rather of text, rather of numbers, rather of mixed kind of stuff. So we can understand visual information in an instant. For example, if you watch any movie, let's say Sholay, for example, कितने ये हाथ मुझे दे दे ठाकुर. So what is this? This is known as visual, and everybody is remember these dialogues, right? कितने लोग थे सांबा, for example, कितने आदमी थे. So what is this? This is known as visuals. So through visuals you can remember, maybe for next 20 years, through 30 years, 40 years down the line, things. But maybe through text, through numbers, you cannot remember the things. So we can remember visually very very fast and very long. Charts or graphs can be processed by the human brain easier than spreadsheets or reports. So is visual data visualization a new things? No, it is not a new things. The concept of using picture to understand data is not new. It has been around for centuries, for maps and graphs in the 17th century. The pie chart was invented in the early 18th centuries. And one of the most cited example of statistical graphics dates back in 1869, when the Persian engineer Charles Minard mapped the Napoleon invasion of Russia, which means there was a map of Napoleon, where you can put your troops, your army, where your enemy will be attacked, the chances of enemy will be attack, and so and so forth. So they have figured it out in 1869, and they make a very good graph out of it. And that is how the Persian engineer Charles Minot mapped the Napoleon invasion of Russia. And that was a very good graphics that what they have made it. So it is long back, maybe the centuries back, the people are using the graphics and the charts for solving their problems. So Minard again, Napoleon is considered as one of the most influential data visualization and one of the world best infographics. And these are some statistics. So this was of course old, but you can understand the things, that which tools are you need to pick up it. Maybe there are 10, 20 tools are there. Out of that, which would we pick up soon, or why it is important? Because people in businesses or in agencies, they are using these kind of tools, or in IT industries, people are using to solve the problems using these tools. Maybe the Python, the R language, Rapid Miner, Excel, Anaconda. Anaconda is a platform where you have couple of tools available. SQL language, which means database, TensorFlow for AI, Keras, Scikit-learn, Tableau for visualization, Apache, Spark, and so on and so forth. So majorly, if you look at four or five tools are very important: Python, R language, Excel, Anaconda. So these are very important tools where you can learn it, and you can pick up at least one or two things, not more than that, so that once you will understand the things, then maybe you can learn other tools as well. So understanding or learning tool is not so big thing, but the concept, understanding concepts, applying into the business domain or in the real time domain is a important element. And this is the spectrum where you have various type of analytics. So one of the agencies, Gartner, which is very popular in the world, they can define the various type of analytics as being as an on a spectrum, which means advanced method of analysis being more difficult but offering increased value. So there are x values and there are x axis, y axis. So one is the difficulty level, and second is the value, which means what value you're generating through that particular difficulty level. So descriptive is, so one is the descriptive, which means low difficulty, low value. Diagnostic means why did it happen, right? So for example, if you have cough or if you have some fever, why did it happen? Because of rain, because of temperature, because of any other reasons, right? So that is diagnostics, right? So why this problem occurs? Maybe the quality of the material is not good, so that my defects are more in the product, and so on and so forth. And what will happen? So if today I'm not buying the material at this price, so what will happen tomorrow? So maybe if the price are escalated or shoot up in terms of cost, then again I have to minimize my revenue, means my profit will be minimized, which means the revenue is more, the cost is more, and then if you subtract cost from the revenue, your profit will be less, right? So the objective is you have to minimize the cost. So if your cost will be increased because of escalation of the cost, revenue, material, then of course your impact are there with respect to profit. So that is how you're going to predict it. For example, if you're making houses, let's say 10,000 houses or 20,000 houses or 1 million houses. So what is the important element in houses? Materials. So if material price, you're not taking the today decision, which means today price is lesser as compared to the tomorrow, but tomorrow price you don't know, but you need to predict it based on your market research, based on your team, based on your market analysis, and so on and so forth. In that way, excuse me, in that way you can make more money out of it. And that is how the analytics would help you to understand the problem statement, and they will give you the predictive element that, boss, based on the last 3 years data or 4 years data, this price can be escalated, and so that you have to take the decisions right away. Next is the perspective analysis, which means how can we make it happen. So this is a pure thing at the optimization, so which means you have some decision variables and you need to optimize the things, that how we can optimize resources, how we can optimize cost, how do we optimize the different job roles, for example. So can we merge two job roles into one? Maybe yes, maybe no. Can we split one job role into three job roles? Maybe yes, maybe no. So in that way you can apply the permutation and combinations, right? So for example, if you have long theater where you have 200 cities, seats are there available, but at one point of time you will see that more audience are not been coming into that theater, So can you make that 200 seats capacity of theater in a two way? So you split 1 by 2, for example, so you can make one thing two, so that you can do the parallel things, and your revenue will be increased. So in that way you can optimize, right? In that way you can optimize through the perspective analytics. And this is how we can define the data is the new oil. So if you have more data, you will be the king. If you have less data, I don't comment on it, but you will understand that if you have less resources, you will not get so that value that the people who has a good sort of data. Because through data you can fetch the insights, you can make a model, training model or the test model, and there you can take the decisions, wider decisions or wise decisions based on the data sets what you have gathered from those businesses. And this is how the core capability of business transformations. So if you look at the older approach where we have PPT, PPT stands for P, stands for people, P stands for process and the technology. And now it has been transformed in the form of new ways, where you can take the decisions of people through the data, you can take the decisions of technology through the data, and the process has been defined through the data. So data comes in between these three elements, these three components, which means people, process, and technology. Earlier we have less amount of data, so that we need to integrate it. Now in the current approach we integrate it through the data. So it is a pipeline basically. So if one customer is coming out into my business and they inquire, कि for example, if I'm a builder and they inquire that I want to buy a flat in Nariman Point in Mumbai, or I want to buy a flat in Pune, for example, near Baner, for example. So my team, my all the stakeholders come to know that one customer comes and they have to inquire the things that do I have inventory of flat in these two areas? If not, then what are the solutions we can provide it those clients? That is the power of pipeline, right? And through data we can make the pipelines so that every stakeholders come to know how many businesses, how many peoples have come, and they inquire the things, and what amount of solutions we are provided to my clients. Maybe 60%, maybe 70%, maybe 40%, and so and so forth. And this is how we define the data. So there are only two ways to define the data. Third approach is the mixed, but I'm not taking into that into the count. So one is the quantitative data, and another is the qualitative data. Quantitative data, which means there is a numbers. For example, how many students are in my class whose height is lesser than 120 centimeter, for example. How many students are there in my class whose height is more than 190 meter, for example. So this is how there's summary statistics based on the numbers. So this is known as quant data. Next is the qualitative data, which means this the sentiments. For example, uh, if in a class one teacher has asked, for example, how many of you like yellow shirts? So maybe that out of 40 students, 5 students says I like yellow shirts, and maybe the other 35 may not. So it doesn't mean that 35 students doesn't like the yellow shirt. But your question is, how many of you like? So five students says, I like this five yellow shirts, which means it is based on the quality of the audience, what they quantify with the help of the question asking element. So good and bad. For example, one food is good for 10 peoples, but the same food is not good for another 10 peoples. So it doesn't mean the food is not good. Food is good, but the choice of the user to take that food is not appropriate according to their choice. So that is again a qualitative data. So one is the quant data, another is the qualitative data, and take this data into the account, and then you try and solve the problems. For example, you can solve the problem of this kind of problems, which means you can take the quant data and then you can find out that what is the correlation between age and height. So over the period of time, if you have more age, your height will be increasing. If not, then this is a negative correlation, means there is a problem. So if the trend is going up, then there is no problem. So now look at the negative correlations. Age of car and reliability. So more and more days your car is means you are using more and more days your car, the reliability factor will be decreasing. So it is a negative relations, which means there is a cost of depreciations. All right. So these kind of things, you can figure it out. And these are the domains of predictive and perspective analytics, where you can apply those in AI and ML, deep learning, and so forth. So which means left hand side is the data, and then you can deep dive into the four aspects, that what should you do, how what will happen, which means the predictive and descriptive. So I'm stopping here. I'm just show you some sort of real time things. Is my slide is visible, for example? Sorry, it's not slide but tool. Yes, somebody's help me. Is my screen is visible to all the audience?
Yes, sir.
Yes. So
Yeah.
for example, let's say this is my data, right? So this data comes from some sort of processes, right? and and this process is, let's say, the Walmart warehouse or some sort of XYZ a warehouse. So if I look at this, this is a customer data where 1,000 customers are there. Now, as an expert, can I draw some insights from this? Practically not, unless and until we transform this data. So the question is, how do I transform this data? So the transformation is the form of graphics. So one is, this is the raw data, which is come from the various layers, data analyst, business analyst, and all that. And now this is the pure data, pure form of data. And now how do I utilize this data to in the form of presentable way? That is known as data visualization. So now if I, let's say, if this raw data I transform it in the form of this way. So now everybody knows that there are only three categories: technology, furniture, and office supplies. And out of these three, technologies are better than the furniture, then furniture are better than that of the office supplies. Then if I can further deep dive into the data, which means I can go for more insights, then I can look at this. Now we have four region into this data: northeast, south, and west. And then these are the profit, these are the sales, and these are the subcategories. So these are the categories, which means technology. Under technologies, these are the subcategories. Same as in the furniture, subcategories of the furniture and office supplies. So these are the subcategories of the main products. And this is again a non-readable format, because this is the text format. And now I can take this data in the transformation way. So this is a transformation way. Now in the all the four regions, central, east, south, and west, now I can find out that product are same, regions are different, but which part of the regions phones are doing good. So for me, it will take a second time to understand that in the eastern regions, the sales of phones are better as compared to western regions, then central regions, and then the southern regions. So the phones, the subcategory is same in all the four regions, but the numbers are different, which means the teams are different, the outlets are different, and so and so. So there are multiple parameters behind it. Now, in these regions, there is no problem because the highest sales are there. If you look at the western region, it is approximate. So there is no problem in the eastern region and the western region. But if I look at the central region, yes, there is a problem as compared to eastern region. The sales are 28% lesser. And if I look at the southern regions, then I have to make the different plan for the southern regions. I have to change my strategy. I have to put more people into it, and so forth. Similarly, chair, similarly, storage. So in that way, if I get these kind of insights, the decision making is very fast. And to understand data in a more reliable fact that where I have to take the decision, where I need to spend more money, where I have to recruit more peoples, where I have to put more outlets, and so forth, so that my productivity, my profit will be more.